Okay, we'll go ahead and get started. Welcome to our Friday Tech Talk with Tulsa City-County Library. Every Friday at noon, you can find us on Zoom for a live webinar of some sort. Today, we have a web developer who works here in town at a company called VetSource. She's also a graduate student working on her master's degree in data science and is here to talk to us today about exploratory data analysis. A topic that I don't know a whole lot about, but I'm excited to learn more. So thank you, Julia, for being here, and I will send it over to her now.
Okay. Hi, my name is Julia, as she said, and I'm doing my grad degree right now in data science. I'm doing it online, luckily. And this is kind of like the first part of data science. So data science is, looking through your data, trying to pull information out of it. And this is kind of the first part of that. What you might do with a new data set is look through it, see how maybe you can put stuff together, see if there are any trends that you might want to explore. And so I'm going to do that R today. So R is a programming language, and it has a lot of packages. Those are basically bits of code that kind of do some heavy lifting for you, specifically for data science. And I am using RStudio locally, but you can actually, there's an rstudio.cloud, and I'll send these to Caitlin to forward to you guys. And so you can have this whole environment that I have right here, but in your browser, so you don't have to go through the install process if you just want to kind of go along and check it out. So we're something a little bit fun. So I have this Rick and Morty data set. So Rick and Morty, if you don't know, is a show that's a cartoon. It's kind of spoofing Back to the Future of two characters that go to different universes. This API has it has like a character data set. So that's what I'm going to pull on today using their API, which is just application programming interface. It's just like a way for me to talk to their servers where this data set lives, and then I can pull it into my computer and then start working on it and looking through that. So I'm going to use libraries. So this HTTR is what's actually going to go fetch my information, this API, and then this JSON light, what comes back to me is structured in a way that you can kind of read it as a human, but to pull it into something that R understands and you can kind of start playing with, this JSON light will turn that into a structure you can actually explore. So to start out, I am using this Rick and Morty API. That's my base. So then specifically, I'm looking at the character set. So I'm actually going to change what I'm showing so that I can go ahead and show you guys this website. So that when you are looking for whatever aid you care about, you can kind of see what information you need. So let me pull this up to the same screen. All right, so this is the API, and it has these, crazy alien characters. This documentation is what I'm looking for. It's going to have that same information that was on the previous page, but this is what that looks like coming out. So if I pull up the document, this is kind of what you're looking for when you want to use an API. You want something that has like nice documentation like this. It's kind of funny for such a silly data set to have such good documentation. So they've actually updated this. I think this is maybe the actual number. I think the previous time I did this, this was an out-of-date number. But whenever you hit it, it will give you back a certain number of records that each record is going to be a character. And they're going to have the of information. So this is kind of the structure we'll be looking for. But this is what it's actually going to return. This is that JSON. So it needs to pull this apart, and I want to put this into a nice row that I can then start pulling apart in R. So let's go back over here. You can see that this is the thing that I'm going to call. So their base API is all here. And then specifically, I'm looking at character. So if we were going to make different calls, I would go ahead and save this and then have my different endpoints. So I just went ahead and left that in the structure. And then I have this idea of a page. So some APIs, they will, you'll have like a key basically, and that kind of helps them limit who has access to this information, or just like how much of your server time, your data they're using. And this one is open, so it makes it a little bit easier to kind of play around with. And I would kind of that maybe if you were looking at trying a data set to play around with. But the way that they limit it is by paginating it. So they're only going to send me back, I think it's 20 characters at a time or something like that. So in order to get the full list, I need to basically repeat this call. So I am going to be sending it a page each time. To off this whole URL, I'm going to stick it together with this paste. So this is smooshing all of this into one big line. And it would actually look like, just for our sakes, let's pull it out so it maybe looks a little bit more clear. So then I add on my character. And then I'm going to add on the page. And now I have one, because I want the first page. And then whenever you're pasting it together, you can separate it with a certain thing, like if I were trying to make a comma list or something. But I don't want any separation, so I'm just specifying I want it blank. I want them all stick together like this. Now I'll hold this over here. And this get comes from my HDR, so it's going to make this call to this URL, and I should get back in here basically a big response. So let's see what that looks like. And in R, when you just put a variable, it's just going to go ahead and print it out. So you see it loading up my libraries here. And then all it gives me back is kind of this response. So this is kind of the header you get back. Let's see if I can repeat that just sitting here in my browser. Okay. Okay. So it's not your actual JSON. So we have to figure out it into that. So now we're going to pull out the actual content, which I believe is raw data. So this is the content. Now this isn't very pretty, but that's what we pull out. So let's see if we can get that. And we're saying that it's going to be text. So we should be able to pull out the text. It has all slashes and stuff. That's basically just the way that the stored. We need to save the quotes because that's how we make strings. So that's why this looks all messy. is so that the computer doesn't mess up having all of these quotes in here. So let's make that a little bit better. So we're using this JSON light and we're saying, okay, so this is JSON. Now I need you to go ahead and flatten it. So that, and make it just like one, let's go back over here. Okay, so it's gonna take it, this results, and it's gonna give me like nice an ID column, a name column, a status column, etc. So there we go. So now this maybe makes a little bit more sense and looks a little bit better. So we have our ID, we have our name, and then we have the status, species, etc. And we see similar things. So this is the data frame. This is really what you're working with for the most part in our, when you're doing an EDA. So it takes all of that information and puts it in something you can kind of slice and dice and look at. And specifically this, the characters portion of that. But so now I have one page of the data I have, and that pagination, I need to go through and get all of them. So if you see here, it's going to tell me how many just characters in general there are. This is the out of date number. And then this is the number of pages. And I could have used this next and just kept calling that until basically it was empty. But instead I just went through and said, okay, well, if there are 20 pages, then I'm going to call this 20 times, changing this each time. And that's going to give me back all of my pages. So now they're up to 30. And this is our loop. So if you've ever done loops before in another programming language, this is pretty similar. I think it's close to like Python. So we have this for loop. And what we're saying, we're basically making some rule about how many times I'm going to be doing what is in here for. So for each value that is in this sequence, so this is sequence of integers, we're going to start at 2, and then whatever our number of pages we got back, so 30, we're going to make basically a long list. Let's visualize this a bit. And if you totally know about lists, then just bear with me. We're going to help everybody else out. Okay, so it's going to look something like this. And so for each value in here, each integer, we're going to go through and say, all right, for 2 is my value. So I'm making the same call as I did up here. Yes, that was a mistake, printing this out. You can make this go away. And then it makes scrolling up a little bit. So up here, I made this paste, and it's going to look like this. So we're making the same call, but we're going to replace the number. And we're going to do that 30 times, well, 29 times. So again, that get, we're going to get the content, and then we're going to be putting them into one big group. So I have this table that I dumped everything into, and I am going to use this R bind. So that's going to take whatever I got here in this particular page, that result set. So the thing that just had the characters in it, results, and it is going to basically paste it on the end of this. So basically page by page, as I go through, I'm going to be tacking on the next 20. And then we're going to go ahead and put out our total. So I should have a much larger set than our initial 20. Okay, and I just posted pages again. So 591 is what we're up to. I have, let's see, now 60 pages to go through. Yeah, so now we see a lot of varied characters, some different species. And at this point, if it were a new data set to me, I might be like just kind of trying to figure out like, okay, what do I have here? Looks like I have some different origins, maybe some places. And then I'm seeing like, oh, look at all these URLs. So if I wanted to keep making calls, look at you know, this specific location, get data about it. So maybe if I continue building a bigger data set on this, I could do that. So let me actually use a summary on my total, because I can look at the individual rows, but maybe I just want to see like what's all in here, and the summary will tell me information about it. All right, let's not do that anymore. You're hiding my output. I think my output is still being hidden. Oh no, it's just stretching it out. All right. Well, I'll go through a little bit of this, but we don't want the same scrolling problem, so I'll hide this again. But it tells us like here are different IDs. And then let's see, with different genders, and it's all just telling us like, oh, it's just telling me that there are characters. Like it's not, it just happens that I'm using a character API, but this is just saying that everything in here is a string. So it's just sending back everything that's in quotes. It's funny. To be honest, this isn't what I was expecting, but that's kind of funny. I might have missed something, but usually what it will do is it will tell you like, probably my problem is that here I have a lot of different values. And then sometimes when you import stuff, it will automatically see that there's something called factors. And it will kind of give you like, oh yeah, there are 3 different values for this. So it will show you like, oh yeah, your status is either going to be this, this, or this. And it will turn it into a factor. I could probably do that with status here, but we'll just go ahead and play with it. But it will like tell you this sort of information, like what is the mean for ID. Of course, IDs are just numbers, so it doesn't really mean anything. But if this were like age, it would give you some quick statistics on it. All right, so here's what I decided to kind of play around with this data set. So since the this show is kind of, has a bunch of different universes, it has a lot of different versions of the same character, and quite a few of these Rick and Morty characters. So they're going around different universes and we're seeing different versions of themselves. And in this data set, there are a lot of, they're usually named kind of the same thing. So it will just be, you know, Rick 357. So here I decided to create just a little kind of simple function. So you can create functions like you do in other languages that will kind of shorthand this instead of me trying to cram this in to another call where it can kind of get messy. So I'm taking in this name and I'm going to categorize it. So it's either going to be a Rick or a Morty or neither. So that's all I care about. Those 3 different types of characters. So I'm using this grepl, which is going to search those names for Morty or Rick, And then it's going to ignore the case. So if it's, capital Morty or if it's lowercase Morty, we don't care. We just want to know if it contains this little string. So then I'm going to set this variable to Rick or Morty. The left arrow is setting it in R. And then we're just going to return it. So in some languages you have to say return, but in this one it's just going to take whatever your last row is and go ahead and return that. And so I have this function and I'm setting it to this name. And so anytime I say this name, I can just pass in the name and it's going to process it. Now here, what I'm actually doing is I'm taking this little tiny data set. It's my little test set. And it's just a list of just a test string, and then actual name that has Rick in it, the name that has Morty, and then another, real looking name. And we're going to apply that across and see how it categorizes them. So we see that it takes in test, and test is neither Rick or Morty, so we got that right. We got Rick Sanchez, and it categorizes that right as a Rick. Same for Morty, and then Summer Smith, it also correctly says neither. So our function is looking good. So now we want to actually take our data set and apply this across everything. So we're going to do that same sapply, and we are doing something called, okay, let's actually read it correctly. All right, so I'm creating a new data set. And so I'm setting that. I'm taking this total, and then I have this thing called a pipe. So I'm basically going to pass in this total to the mutate date function. It's just a little bit of a cleaner, once you start playing with this more, way of passing it in. For me personally, having done a lot more like other languages, this can be a little bit confusing. So another thing you can do, usually when it's doing, it's actually just shorthand for data equals total. So it's just like another parameter. But when you see that, that's what it's doing. And okay, so we're mutating it, and we're going to make a new field, this Rick or Morty, to store our status of what type of character this is. We're doing that same sapply to name. Now this names is a list here, but this name is actually referring to this field. So it's taking my data set total and it's pulling out like a list this name column. So it's saying names. It's going to have basically a long list that says Rick Sanchez, Morty, blah, blah, blah. And it's going to pass each one of these to them and just add on a new column to it. So I'm saying that across all of the data set names, I want to apply the function I just created. And I'm going to add it on and make a new data set from that. So I have my all characters data set. But if I were gonna look through here, maybe I already know what I care about. So I've looked through the columns and I hate having to scroll all the time. So what I'm gonna do is set this to only a certain number of columns. So I like to do this. You can do it with passing the index of the variable, let's see, the column. So like here, this would be column 1, 2, 3. It starts at 1. But I prefer the passing it this way. It just makes more sense to me. I don't have to count what the index is. So that's what I'm doing. So I'm going to grab the name column. I'm going to grab Rick or Morty, my new column that I created, and then status and species. The other nice thing about this is I can move these around. So whenever I created my new characters, actually, I don't know if I actually ran this. So let's start running some of this and make sure that I have these. I think I already did this one, but we'll just refresh the set. Yeah, that's where it's yelling at me. And then we ran that, yep. Okay. So this is, I should have my new field. It's gonna be end, right, at the very end. So if this is the field I care about, I want it to be much closer to beginning. So now I have a much more abbreviated. Still got to scroll over one, but deal. So I have my fields that I care about. Now let's actually look at this in a different way. I mean, we can always open up Excel and do this. Not exactly fun. So what else can we do with it? We can do this GG pairs. Hopefully it's gonna run for me. There we go. Which we'll take some fields and essentially we are comparing each field individually to one another. So here I have my Rick or Morty status, and then I have my actual status. So this is whether or not they are alive, dead, or unknown. And then species. I also just color it by species, so that's why all of these are kind of sliced and diced a little bit with some color. And showing you the different species within each of these. This is Morty, this is Rick, and this is neither. And then where they meet their own column, it's just the distribution of that particular status itself. So there are more alive characters than there are dead, than there are unknowns. And then we have so many species. One thing you'll run into, especially with this, is there are so many species that it's kind of hard to see. So that's one thing about G pairs is sometimes when you have a lot of categorized stuff like this, it can get kind of messy when you're trying to show it in against other things that are also categories. Okay, so I want to look at this health status. And actually, let me kind of just do this one by one. I'm also going to use this thing called ggplotly. So let's run just this one. Just those lines. Let's not get too messy. Okay, so here we go. Now, one nice thing about this is before we ran into this issue, this is just an image that it's outputting, so I can't get any more information from it. But when I use ggplotly, and I'll come back and explain this a little bit more, what I have now is I have this key, but now when I hover over things, I can get more information. So even if you have like a pretty messy, you know, something that has a lot of different levels to it, then you can still like kind of dig into it, even if you can't necessarily read the labels. It makes it a little bit easier to dig into like scatter plots, where maybe you have a random outlier. It makes it easier to say like, hey, what is that outlier? And you see like, oh, it's, you know, the alive status count. So coming back up here, so I have that new data and I'm using that same pipe. So now we're going to start stacking our plot information on it. So I'm using ggplot, and I believe this is short for aesthetics. But I have some important information, like what are we actually plotting? So we're plotting species. That's our x-axis here. So down here you see our x-axis is species. And we're making a histogram here, so we need counts. So here I say like I want a histogram out of this, and specifically the stack that I want is count. So I want you to go through here and count each of the species that you find and give me a histogram of it. And then my feel is the color that I get. So what is this inside color that we are breaking down in our key? So it's going by status. So we have all of the alive ones in red and etc. And then with this histogram, I also have my own color here mapping, and that's actually, I believe, changing the outline color. So we could even give it another level, and I'll show that, but it doesn't really, from what I've seen, doesn't turn out great. So it's good to kind of leave them the same. Now, the title, just, you know, it helps me when I'm looking through later, know what's going on. But also, you know, if you want to pull these out, it's going to make it a better experience for them to have, you know, even if you're just literally writing what the X and Y axes are, sometimes it can be helpful. And then I get to pick my own color. That's another nice thing about ggplot, is that I don't have to just use these kind of built-in colors. So looking over here, now that I have ggplot, I can see that this big spike here is human. I want to go in and look in more at these other ones and see scale a little bit better for everything else. I want to go ahead and remove something. So I am going to use this filter function. It's going to build me a new data set. I'm not going to save it to anything because I'm just kind of using it to graph. So I'm, instead of what I did with new data, where I built a new data frame, I'm just going to go ahead and directly pass it to all of my plotting stuff. So I'm going to use filter on my new data, and I'm going to say my column name and then not human. So this is going to look at basically anything where that field is not human. And then we're doing just the same stuff. The only difference here, I'm changing this title. So let's run those specific lines again. Okay, so now we can kind of dig into it more and kind of see a little bit more of the distribution of everything else. And, you know, I see this another spike again. I can almost see, oh, look, maybe this is vampire. So maybe I'll go ahead and remove alien as well. And let's see. I think that was me playing with stuff last time. So instead, we'll skip right to the no humans or aliens. Oh, I didn't want to, again, I did decide to go ahead and put it into a data frame. So this is, I skipped the whole creating a new data frame before, but now I'm doing something a little bit more complex. So I built out this bigger, I basically did it step by step, and then I showed how you could do it in one single filter. So here, go ahead and run all of this so we'll have it. I'm going to filter out first the humans, and then I'm going to take that new data frame I made, filter out the aliens, and then I'll have a no aliens, no humans data frame. And then this is how you would do it in one line. You can chain them, and it's just like a single and. Say I would like both not alien and not human lines only. And we see no humans. So now let me pull out, same plot, but now we're saying no humans, no aliens. And let's see what this looks like. All right, we still don't really get to see the labels, but now we kind of can see at a scale how everybody else in the galaxy is doing as far as their, you know, status, whether or not they're alive, dead, or whatever. And maybe we can see, hey, what's all dead? Oh, good, diseases are dead. Wouldn't that be nice? if that were true everywhere else. So all of the diseases are dead in this data set. That's good to know. And now we can kind of actually see this. All right, parasites are dead. That's a pro. But now I have this new field that I created about Rick and Morty. So I want to dig more into not just the species, but just looking at Rick or Morty. How are they going to be alive or dead? Unknown. So I have our initial data set, and I'm going to split it out by Rick or Morty. So it should look similar to this kind of split, where we're looking at Morty, neither, or Rick. And I'm going to fill by status again. So it's going to look similar to this, where it's splitting it out into our 3 different levels. Okay. So we see that there are quite a few neither that aren't Rick or Morty. And it looks like there are quite a few alive. Seem to have a surprisingly large number of Ricks that are in the dead status compared to Morty. So let's get rid of neither. So we can kind of see, we can see that these are separate, but how much separate are they? And maybe how many unknowns are there? It's a little bit harder to tell at this angle. So let's pull out just Ricks and Mortys and look at them. Okay, so now we can kind of see, just compared to Mortys and Ricks, that there are definitely more Ricks, but we do see that there are definitely more dead Ricks than Mortys. And we have actually more alive Mortys, even though there are fewer of them total than there are alive Ricks. So pulling it into just this own status based on whether or not they have Rick or Morty in the name, we can kind of see just the general number of Rick or Mortys and how they fare in a series on whether or not they're dead. So this is going to get to kind of doing multi-dimensions, so looking at more than just alive or dead status in coloring. So this is me trying to outline as a different level. So this is what that looks like. It's a little pretty messy. So we have, let's see, let's just start again. So we're filtering again on neither, and then I'm going to do it by species. So we're back to our species model, and looking at filling Rick or Morty. So these are divided into 2 different colors. There are only 2 here filled in. And then here I have colored by status. So we have 2 levels fill in surrounded by 3 lines for the histogram. So let's see, yes, good, I did ggplot, so we're at least a little bit saved by that. So when you hover, you can see, all right, so the status is dead, so it has the black outline. And then this is Rick, so it has the green fill. This is a bit garish. I think I did actually maybe, oh, I just selected the fill hues. I didn't change what, this is definitely the defaults for the lines. So it's pretty garish, pretty hard to see. So a slightly better way to do that is to maybe pull it into 2 different graphs. So I am going to just look at Rick this time, pull him in. And then I am going to, still the X is going to be species. my fill is going to be status, but now my color is also status. So the fill and the lines are going to match. We're just going to go back to having one dimension that we're trying to color by. And then I did the same for Morty. So let's look at Rick's. And then Morty's. So we see this same spike. They're mostly human Ricks and Mortys. And it looks like the human Ricks have a very high mortality rate, definitely compared to the human Mortys. So I think that's as far as I'm going with this data set. This actually took quite a bit more time. So we'll save this real quick. And this is all I have for this data set. And this was using the API. So this was actually pulling our data from the internet. And next I'm going to go to the COVID data set. So this is from, this data set. It's supplied by the Johns Hopkins set. This is the really famous map at this point. Let's see. There we go. The data that is hanging out, themes that populates this dashboard that everybody looks at all the time now. So here we have broken up by countries, our numbers. So we have just confirmed cases. We have an idea of deaths and then recovered. And we'll see that in our data set. And they're also mapping it, so they have some sort of location information from these. So this is available, it's uploaded very regularly. I just, in the GitHub repo that I'll supply you, since we're gonna run out of time, it will have one of these days in here. So last time I did it, it was 05, or it was April 18th was our latest date. And now I just pulled in 21st. So let's hope that I did that right, and we should be able to pull this in real easy. And again, we're just gonna look at the raw, what's pulled in. So this CSV is just gonna be the comma separated list of this data. So it's just a bunch of raw text basically. And we have information on the state, we have a country, and these are being pulled in. This is what I was talking about with factors. So let's see, maybe this is better for our summary information, since we're actually understands what factors are. Yeah, so we have 52 different states. This is, I believe, the US data set. There are actually two different sections in here. I'll show you. I think it's this one. Yeah, this reports US is the one that I'm using. And so here we can kind of see all of the columns pretty easily and some information in them. Again, this lat long, it's trying to use them and give you summary information on them. It doesn't really have these, you don't really have necessarily an average latitude and longitude. Maybe makes more sense if you had a smaller area that you were looking at. And then we have the confirmed cases, the deaths, the recovered, and the active cases. This FIPS will be helpful to us. It helps us tie a location instead of the lat long. It gives it to an idea of like a state. It's gonna have a certain FIPS code. And some of this is actually you could pull out your own information from these other fields, but they've already given you some summary information from these, like an incident rate and a mortality rate, which you could calculate yourself from confirmed versus deaths. But so that just kind of gives you an idea of what information is in this data set. I'm going to start plotting the data using our ggplot, and then we're going to use this tidyverse. So let's got to remember to do this piece by piece. Sometimes whenever I'm playing in these, so this is an R markdown. This isn't just R. Whenever you run, you know, like program files, usually we'll just go through and run everything. And this is kind of similar to Python notebooks. It allows us to have this information here. So we can type in just notes here. And it's not actually related to the code that we have here at all, but it gives you a place to maybe do some explanation about what you're doing down here. Maybe some tips on how to run it. Like up here, if I were going to have this, I would say change with new COVID file, most up-to-date info. And at the end, I'll just go ahead and do it. It has this thing called knit. And what that's going to do is, I've been running these piece by piece, but since we're so close to out of time, I'll just go ahead and knit this. So this is going to take a little bit. Okay, it's going through. And it's going to be running this line by line, and it's going to give you the output. And I might shorthand and skip over to some of this looking through. So when we look at that raw data, it does print out everything. And so it can get kind of messy if you're going through and just dumping everything like I was in the last one. So this is the plot COVID raw. What I'm doing here is, I think this is like, yeah, it's doing kind of the same thing as pairs, but only more messy because it's literally doing it with every field. So something like this, it might not be super helpful, but it might give you like a quick overview, like, hey, some obvious trends, what am I going to hit? So maybe if you did have something that you were wanting to look for trends really quickly, you might do this if you were completely unfamiliar with the data set and just wanted to see like, hey, where are the related fields? So first here, I have that same raw data set, and I just want the first 10. So we're just looking at the top 10, and we're going to do the deaths versus the confirmed. So we're looking here, actually the kind of mortality rate. And we have, I'm filling it by the province state. So this actually is not maybe the top 10 you might be thinking of. This is actually literally the first 10 in that data set. So that's why we have Alabama, Alaska, American Samoa, etc. It's in ABC. So that's the top 10 of this particular data set. And we're going to look at those in ggplot, at which one of these is the most. We see California and Connecticut have similar numbers of deaths, but they have quite a few, like quite a gap here in their confirmed cases. So we might put that in the back of our head and say, yeah, we'd like to look at that later. And so instead, let's do the same kind of thing, but let's go ahead and do everything. Here in ggplot, I would show you, but it's quite a mess. If you don't do ggplot and you just bring it out, this key can almost destroy your whole screen. So another plot is it nicely lets you go ahead and display everything if you wanted to. But again, you can just hover, and we see that this New York has just far and above. You can really see the scale of how much New Jersey is next, but New York is still very far ahead of everyone else in confirmed cases as deaths. And then we see much like a big cluster just because of the nature of that gap. But we see the next few states up here. So now, since there is such a gap, if I wanted to dig more into, okay, what's going on in here, I want to look more closely in this group, I'm going to filter out again. So this is where I'm doing that chaining. And one thing you'll notice, even though we have all of these different states, province states, this has other countries in it. So when I first looked at this, I thought it was just a set. That's another thing that doing a quick data analysis can give you, is seeing like, oh, I saw Hubei. I think it's over here somewhere. Maybe it's not anymore, actually. I might have surpassed it. Well, at the time, Hubei was like up here, and I filtered that out so that I could kind of look more at the rest of this closely, because it was like right next to these. So now I'm just looking at everything but like the top ones. And we can see that we have some more spread. We still have some definite clustering. So there is still definitely, let's see, if this works the way I think it does. Oh, no, that would take way too much. I can make them go away, but I can't just highlight the one that I want. So it's gonna be hard for me to find our little baby Oklahoma in here somewhere. Yeah, there we are, okay. So here we are in Oklahoma. We're at this end of it. We have 304 deaths and then 56 confirmed cases. So we can see that we're kind of more towards the lower end of this scale. But if I wanted to look at more specifically the top ones, so more like what's going on in this end of it, then I can say, okay, show me just the ones that are above 700. So I'm doing that filter again, but now instead of just looking at the characters, I'm going to give it a greater than value. So I just want to look at ones that are above 700. So doing the ggplot again, same fill for province state, and then I'm doing plotly again so I can kind of look at them and hover. So we do have, I think, quite a few more than the last time I ran this. I think it makes sense, it was a month ago. This over 700 case. So we see the list here, but then again, we can hover and see, okay, the ones that are at the very edge, where are they? And if we had, maybe if we were looking at, there's a cluster here, but then we have some that are getting bigger over here. We might look at these, and maybe we would pull from another data set here at this point, and maybe we would start looking at, okay, what changes a weight in here to bring it up to a higher here. Maybe we'd look at their populations and just say like, okay, that's like how many people have been infected. So this kind of gives us a view of this particular data, but maybe we'd want to dig more into like, okay, why are the Northern Mariana Islands. Like if you didn't know anything, I'd say like, oh my goodness, they have so few deaths and so few confirmed. You know, if this weren't a data set we all kind of know about, states, that might be like, oh, a breakthrough, let's see what they're doing. But if we pulled in more information like population, then that would kind of help us tease like what's really going on there. It's like, oh, this is a very small island. Of course, they're going to have smaller numbers. But in my last 5 minutes, we'll use those FIP codes. So these FIPs, I'm filtering it to just the US because I want to map all of this. We have states, so we should be able to put these onto a state map. So again, this is printing out the data set. Now, we saw that huge gap. We're going to see that same thing here called a heat map. So it's going to make the lighter ones are going to be those with smaller numbers here. And by smaller numbers here, what I mean are, let's see where I grabbed it. Where am I setting it? Okay, the values it's looking at are deaths here. I'm using a US map library. And what it's doing is it's taking those, it gives us the FIPS codes, and it knows that whatever code is going to match to like New York here, and it's going to color it according to the scale, the color scale. So it gives you a scale across states of how many, the way that John Hopkins is doing this is through circles that are filled in. So bigger circle means there have been more incidents. And here we're doing it by color. So we see these darker New Jersey and New York, you know, they basically white out everything else in comparison. Like that's how many more cases that they have. So if we remove New York, then we start to see a little bit more color, but then immediately New Jersey becomes the next one. And when we remove those two, we can kind of start looking through and seeing like, okay, how does everyone else compare? Now, you know, this is removing information, and you might just do this to kind of like show, okay, how are maybe the everything but the top 5 states doing, and who is maybe our next state to look at. But you would want to leave in some information like this if you were plotting, so you can see like, you know, look at the scale, look how many more cases there are. Okay, and now let's see. Oof. I must have messed up my data here because now I just have the US and I have a single plot. I think I messed up. Let's see, we have 3 minutes. I don't think I can fix this in 3 minutes, but I will fix it and check it in, and I will send that GitHub link to Caitlin. So what we should be doing here is basically looking at the country levels, but when I filtered it by the US, it looks like later on, whenever we're just doing this like line by line and going through everything, I filtered it out. So this will be in the GitHub. We only have 2 minutes left, but I hope you guys enjoyed the very, very quick look at R. I really enjoy it, and let me know if you have any questions.
Well, Julia, thank you. I know data analysis is something you hear about a lot, and definitely see people applying a lot, but it's kind of fun to see the back end side of it. If anybody has any questions, feel free to drop them in the chat. And if we don't get to them today, just let us know, and I can always email Julia and see if she can answer me. We also live in the same house, so it's pretty easy to find her most days. But thank you all for coming out today. I will be putting this talk up on YouTube, and you can access it later. And I'll also send out some links that Julia mentioned, like to the GitHub, as well as where she got some of her data from that she was working with. So I hope you all have a great weekend. Enjoy your holiday.
Thank you guys.